Hi everyone, in this lecture I am going to discuss about the principle involved in UV visible spectrophotometry. What is UV visible spectroscopy? UV visible spectroscopy uses the electromagnetic radiations UV and visible radiation. The UV radiation have a wavelength from 200 to 380 nanometer and the wavelength of visible radiation is 380 to 780 nanometer. It studies how the molecules absorb light and it is also called as electronic spectroscopy. Why it matters? It helps identify the chemicals and it also measures how much of a substance is present. It shows details about molecular structure. So with the help of UV visible spectroscopy, we can do both qualitative as well as a quantitative analysis, and with the help of that we can be able to analyze the concentration of substances present in the pharmaceutical component as well as some other components, and we can also elucidate the structure that is present inside the dosage form or some other components. And how it works, molecules absorb light to excite the electrons. Only specific light wavelengths are absorbed. This absorption is unique to each substance. So the principle involved is absorption. The electromagnetic radiations UV or visible radiation will be absorbed by the molecule, and the electrons present in the molecule will go from ground state to excited state. And within that period, how much amount of the light radiation that were absorbed by the sample will be recorded and it will be identified. So it will be a direct identification of the concentration of components that are present inside our sample cell with the help of absorption. The key term involved is lambda max. Lambda max is the wavelength of maximum absorbance. The wavelength where a substance absorbs the most light is called as lambda max. So within that given wavelength region, that is from 200 to 800 nanometer, the particular substance will have a highest absorbance only at a particular wavelength, and that is called as lambda max. It helps to identify the substances. It is like a fingerprint of that substance. If we dissolve that substance using a suitable solvent and measure its wavelength, that is lambda max in UV visible spectroscopy, it will have a highest absorbance at only particular point, and it will be similar. It will not be similar for some other components. So it is like a fingerprint. It stays the same even if the concentration changes. If the concentration changes, only the absorbance will vary, but the lambda max will remain the same. Absorbance and concentration. So if there is a more substance, there will be a stronger light absorbance. You can see it in the graph. This graph consists of a spectrum of absorbance versus wavelength, and in that we are seeing the carbon at different concentrations. In all the different concentrations, the highest point is the same, that is the lambda max is similar, only the absorbance varies. The carbon with the highest concentration will have more absorbance. The lambda max does not change with concentration. Example graph of absorbance for different concentrations. So then uses of UV visible spectroscopy. It is used to identify the substances. If we have the API, we can compare it with our sample to identify what kind of substance it is, and to measure the concentrations, and to learn about their molecular structure, and to study their physical properties and sample purity. So first use is identifying the substances. Each substance has a unique absorption pattern. Example check purity of solvents or identify organic compounds. So they all have a unique absorption pattern. That is, if you see the spectrum of your component, the pattern of the spectrum will be similar. And then measuring concentration. Higher concentration is equal to higher absorbance, which means if our concentration increases, the absorbance will increase. You can see it clearly in the graph. When compared to 10 ppm, 50 ppm have highest absorbance. So it is used for water testing, food and drug industries. And then molecular structure shows if the molecules have double bonds or specific groups, that is C double bond O, helps understand how molecules are built. So with the help of the spectrum, we can identify if there is a double bond or triple bond present inside our compound. Then measure properties like extinction coefficient, how strongly a substance absorbs light, and melting point of proteins and speed of chemical reactions. And then sample environment. Impurities or solvents can change absorption patterns. Example, peaks may shift or widen if impurities are present. So if our sample have impurity, when we compare it with the active pharmaceutical ingredient, the graph or spectrum will show an unusual pattern. So with the help of that we can identify if there is any impurities are present in our compound or not. Then electronic transitions. So what is happening, why this principle is happening is because the electrons are moving. There is an electronic transition that is happening. The light excites the electrons to the higher energy level. There are 4 types of transitions, that is n to pi star, pi to pi star, n to sigma star, pi to sigma star, sigma to pi star and sigma to sigma star. Each type needs a different amount of energy. The types of transitions are the sigma to sigma star needs higher energy in simple hydrocarbons. This kind of transition happens when our sample consists of a hydrocarbon and it requires higher energy. So hydrocarbons are something that have a similar single bonded components. And n to sigma star transition will happen in molecules with oxygen or nitrogen. They require medium energy for transition. And pi to pi star transition will happen in double bond components and they require very lower energy. At n to pi star transition will happen in compounds or molecules like ketones or aldehydes, and it require very lower energy. So with the help of these transitions, the energy changes will happen inside the molecule